Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 24, Applications of Systems of Equations and Inequalities. So now we're applying our knowledge to real-world situations. So the opening exercise says, in Lewis Carroll's Through the Looking Glass, Tweedledum says, the sum of your weight and twice mine is 361 pounds. Tweedledee replies, the sum of your weight and twice mine is 362 pounds. Find both of their weights. So the first thing we have to do is represent what we're going to let our variables equal. So we're going to let x equal the number of pounds Tweedledee weighs, and we're going to let y equal the number of pounds Tweedledum weighs. Okay, so then we're going to set up equations. This is a system. So Tweedledum says the sum of your weight and twice mine is 361 pounds. So Tweedledum is y. The sum of your weight and twice mine. Your weight would be, that's a y by the way. Let me try that again. So Tweedledum is y. Tweedledum, y. And Tweedledee is x. So Tweedledum says the sum of your weight, that's x, and twice mine, and means the sum of and twice mine is 361 pounds. So it would be x plus 2y equals 361 pounds. Setting up the second equation, again, Tweedledum is y, Tweedledee is x, and Tweedledee says the sum of your weight, which is y, and twice mine, and 2x, is 362 pounds. And now we have to find both weights. So now we have a system of equations, and I'm just going to rewrite this second one, so let's just rewrite them. So we have x plus 2y equals 361. Putting it in standard form, I just need to switch the x's and the y's over here, so I have 2x plus y equals 362. Alright, so I need to solve by elimination. So if I multiply one of these by 2, if I multiply the first one by 2, negative 2, then the x's will cancel. So let's do that. So when I multiply through, negative 2 times x is negative 2x. Negative 2 times 2y is negative 4y. Equals negative 2 times 361. Well, 2 times 1 is 2. 6 times 2 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. And a negative times a positive is negative. And then I just bring this equation over. 2x plus y equals 362. And then I add them. Negative 2x plus 2x is nothing, 0. Negative 4y plus y is negative 3y equals, and when I add these, be careful with negatives, I'm going to take negative 722 and I'm going to add 362 to it. I could have just subtracted and kept the sign of it smaller, so that's negative 360. Divide by negative 3 on both sides, and my y equals negative divided by negative is positive. 3 divided by 3 is 1. 6 divided by 3 is 2. So y equals 120. So Tweedledum weighs 120 pounds. So I'd say that. Tweedledum weighs 120 pounds. Tweedledee weighs and now I need to solve for x over here. So I just take any one of these equations, either one, and substitute in my y. So since I just have one y here, I could do it here, or I could just, I'm solving for x, so let's just deal with the x. So if we take x plus 2y, and y is 120, equals 361, and solve, we get x plus 120 times 2 is 240. And then when I subtract 240 from both sides, okay, 1 minus 0 is 1, 6 minus 4 is 2, 3 minus 2 is 1. Then Tweedledee weighs 121 pounds. So let's just move this out of the way. Whoops, undo, undo. All right, try that again. Just move that down there, and okay, it exploded it, so I will just write it in here. Tweedledee weighs 121 pounds. So my answer is right here. Tweedledum weighs 120, Tweedledee weighs 121. Okay, next the example says, Lulu tells her little brother Jack that she is holding 20 coins, all of which are either dimes or quarters. They have a value of $4.10. Okay, so her total is 20 coins, and they're dimes or quarters. So the sum of all the dimes plus all the quarters equals 20 coins. So we're going to let D equal dimes, number of dimes I should say, and we're going to let Q equal the number of quarters. Okay, so we have to tell our reader what we're representing our variables as. So D is the number of, I should say that, number of dimes, and Q is the number of quarters. So D plus Q equals 20. The sum of all dimes and quarters equals 20 coins. And then we have to, and then we know that the dollar amount is 410. So that is going to be 4.10. And a dime, we don't know how many dimes we have, but we know a dime is 10 cents. So it's 0.1 D plus, and a quarter is 25 cents, 0.25 Q. So we have to put the quantities in for our coefficient. So if I have one dime, I have 10 cents. If I have two dimes, I have 20, and so on. And if I have one quarter, I have 25 cents, two quarters, 50 cents, and so forth. Okay, so now that I've done this, I need to represent a system and solve it. So let me just move this down here a little bit so I have more room. Okay, they're all lined up nicely, and then I need to do something to one of these. Let's see, if I multiply this by 10, negative 10, I will get dimes to cancel. So let's do that. So I'm going to multiply by negative 10. When I distribute, negative 10 times 0.1 is 1. That is just going to give me a negative D, because negative 10 times a positive 0.10, or positive 1/10, is negative 1. And this one's not going to change, so let me just bring that over. D plus Q equals 20. I also could have done something to get rid of the Q's. I could have multiplied by negative 4. Okay. Anyhow, negative 10 times 2.25 is negative 2.5 Q equals negative 10 times 410 is negative 41. And then I'm going to add these two. D plus a negative D cancels. Q plus a negative 2.5 Q is a negative 1.5 Q equals 20 plus a negative 41, which is negative 21. I will divide both sides by negative 1.5 to get Q. Negative 1.5 on this side. These cancel, and I get Q equals. Okay? And let's just use the calculator for this to save time. And negative 21 divided by negative 1.5 equals 14. Okay, So we have 14 quarters. Well, 10 quarters is $2.50, and 4 more quarters is another $1, so that's $3.50. So I'm guessing we have 6 dimes, but let's finish it this way. Then we take our D plus Q equals 20 and say D plus Q, right, here's our Q, equals 20, using the original equation in green, and then subtract 14 from both sides, and that gives me number of dimes is 6. So if I have 6 dimes, that'd be 60 cents. If I have 14 quarters, remember 10 quarters is $2.50, 4 quarters is $1, that's $3.50 with 14 quarters. 60 cents plus $3.50 equals $4.10. Okay. Okay, page 2 brings us to exploratory challenge. It says, at a state fair, there's a game where you throw a ball at a pyramid of cans. If you knock over all of the cans, you win a prize. The cost is 3 throws for $1. But if have you an armband, if you have an armband, there's a misprint. But if you have an armband, you get 6 throws for $1. The armband costs $10. Write 2 cost equations for the game in terms of the number of throws purchased. One with an armband and one without. There's another, oh no, one without an armband and one with. Okay, so we're going to let X equal the number of throws and let C equal cost. Alrighty, so here we go. Let's choose red for starters. And let's just underline stuff that matters. The cost is 3 throws for $1, or 6 throws for $1 if you have an armband. Okay, the armband is $10. So there's all the information we need to do this problem. All right, so we need equations. So if I don't have an armband, without an armband, C is the cost, and that equals number of throws. So the cost is 3 throws for $1. So how could I represent this as an equation? Let X equal the number of throws, 3. Okay, so we want to figure out what we're going to use. So think of it this way. 1/3 of 3 equals 1. So if our cost is $1, then it'd be 1/3 times the number of throws to get $1. So it's 1/3 of $1, 33 1/3 cents per. So then when I clean this up, it would just be 1/3 X. So C equals 1/3 X. So if I plug in 3, 1/3 times 3 is 1, and C is 1. Okay, and that is without armband. And now I'm going to do with armband. So that's going to be C again. But in this case, think of it the same scenario as here. 1/6 times 6, which is our X in this case, is $1. So there's our 2 equations. But we also have to pay for the armband, and the armband costs $10. So there's our 2 cost equations. If I don't buy an armband, every throw is going to cost me 1/3 of $1. If I do have an armband, it's going to cost me $10 for the armband plus 1/6 for every throw. So if I throw 6, it's going to cost me $1 plus the 10 for the armband. That's $11. So there's our 2 equations. All right. Part 2 says, graph the 2 cost equations on the same graph. Be sure to label the axis, show an appropriate scale. Okay, so let this be our C, so that's cost. That's our y-axis, if you will. We're going to call it our c-axis. And this is going to be our x-axis. Well, what does x represent? Number of throws. Okay, be sure to label the axes and show an appropriate scale. Alrighty. So what scale should we use? Alright, so multiples of 3 are multiples of 6. So I guess if we did 3, 6, 9, 12, that would make sense. So we can graph this easily, right? The multiples of 3 and multiples of 6, 3s and 6s will work. So we'll go in multiples of 3. So every square across the bottom is worth 3, but I'll just mark every other one because they're too close together. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. Okay. Going up the side, we could start out, we want to break this squiggly, and we could start out, because we're not going to do less than 10. Alright, so if that's a break right here, that's what, it wasn't a 5, it's a break. So when we don't start at 0, then we do a squiggle like so. And my first point is going to be 10 up here. I'll start 10 here, and I'll go in increments of 1s. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So now I'm going to graph these. So let x equal number of throws. So the cost without I'll do in red, 1/3 x. So if x is 0, it's at 1/3. If x is 6, we're at 2. If x is 12, we're at 4. 12 times 1/3, or 12 divided by 3 is 4. If we're at, so let's go all the way out here to 30. If we're at 30, 30 times 1/3 is 10. So if we're at 30, we're right here. So we could get 30 throws for 10 bucks. And our rate of change is 1/3, so that means go up 1/3. So that's up 1/3. And I'm going in what? Multiples of 3 here. So 23. Up 1/3 is right here. Up 1/3 is right here. And now you probably see why I did increments of 1 this way and 3 this way, because that is our rate of change, 1/3. So if I go up 1/3, that's right here. Up 1/3, up 1/3, up 1/3, and so on. So let's just check my last one. So if I throw 60 times, 60 divided by 3 is 20, and if I come over here, I'm at 20. So there is my graph for number of throws starting at 10. If I start at 10 on the other one, I buy an armband, it costs me 10 bucks. 0 throws, it cost me $10. Up 1/6 is right here. Up 1/6 is right here. So let's check that. If I throw 12 times, 12 times 1/6, or 12 divided by 6 is 2. 2 plus 10 is 12. I'm on the 12. So I'm going up 1/6, which is 2 actually. Up 1/6, up 1/6, up 1/6, up 1/6, and so on. And we meet right here. 60 throws, regardless of whether we have an armband or not, will cost us $20. So 3 says, does it make sense to buy the armband? Well, here's the armband. So it's costing us more money for less throws until we catch up to this red one. And then the red one's going to exceed and the green one's going to be cheaper. So it only makes sense to buy an armband if we throw more than 60 times. Okay, page 3 brings us to part B. A clothing manufacturer has 1,000 yards of cotton to make shirts, and pajamas. They're making shirts and pajamas. They have 1,000 yards of cotton. A shirt requires 1 yard of fabric. Okay, so first of all, they have 1,000 yards of cotton total. A shirt requires 1 yard of fabric. And a pair of pajamas requires 2 yards of fabric. It takes 2 hours to make a shirt. Okay, oops. And what color haven't I used here? Red, green, blue, purple, I guess black. 3 hours to make the pajamas. And there are 1,600 hours available to make the clothing. So there's our total. What are the variables? Okay, so the variables are number of shirts made and number of pajamas made. So we can just say S for shirts and P for pajamas, or we could use X and Y. Okay, but we'll get to that. So it says, what are the constraints? Okay, well, there's only 1,600 hours available to make the clothing, so there's a time constraint. And there's only 1,000 yards of cotton to make them, so how much time the manufacturer has and how much material is available are the two constraints. 3 says to write inequalities for these constraints. Okay, so let's get back to naming these variables. Number of shirts made. Let's just call that X. So X, number of shirts is X. And number of pajamas is Y. Write inequalities. So with respect to shirts, well, we can make no shirts, but we have to make, or we could make positive, but we can't make negative numbers of shirts. So the number of shirts made has to be greater than or equal to 0. And same goes for the pajamas. We can't make negative numbers of pajamas, but we can make 0 or more. So Y is greater than or equal to 0. So that deals with just the number of shirts and pajamas made. Okay, so a shirt takes a yard and pajamas require 2 yards. So if we're going to do an inequality with respect to the amount of yardage we have, and the total yards is 1,000, then we say 1 yard of pajamas. Well, let's keep the color code going. Okay, so a yard of fabric for a shirt. Number of shirts is red, X. So 1 yard, 1 times the number of shirts made, 1 yard times the number of shirts, plus, and then the number of yards to make a pair of pajamas is 2, so that'd be plus 2Y. And our inequality would be less than or equal to our total number of yards, which is 1,000. So 1 yard per shirt plus 2 yards per pair of pajamas has to be less than or equal to 1,000 yards. And then if we're going to talk about time, it takes 2 hours to make a shirt, 2x, plus it takes 3 hours to make pajamas, 3y, has to be less than or equal to our total time of 1,600. Let me keep with the colors here. So that's got to be less than or equal to 1,600 hours. So there are our 3 inequalities, or 4 inequalities actually. Okay, so this might be a little confusing for you at first, but let me just use black here. X is greater than or equal to 0. Well, this is going to be my x-axis, And my x-axis, that represents number of shirts. So if you label your axes, it makes it easier. And y is number of pajamas, PJs. Okay. So I know that x has to be greater than 0 and y has to be greater than 0. That puts us in the first quadrant. So that's all this is telling us. We're in the first quadrant. Now I have two inequalities. X plus 2y is less than or equal to 1,000. Okay. So that means, and what is 1,000? 1,000 is number of yards of fabric. And 1,600 is number of hours. So what I want to do is solve this for y so I can graph it easier. So if I just take this first equation here and say, or inequality, x plus 2y is less than or equal to 1,000, and solve for x, or put it in linear form, let's just solve for y, then it'd be subtracting x from both sides, giving me 2y is less than or equal to negative x plus 1,000. And then divide by 2 would give me y is less than or equal to negative 1/2 x plus 500. So when x is 0, we're at 500. So let's just call this 500 right here. And I put a dot, and let's use red for that. So if I don't make any shirts, 0 shirts, I make 500 pajamas. And then I can choose some values here. The easiest way to do this is find your x and y intercepts. Okay, and that should be another 0 up here, it's 1,000. So let's just do it that way. So now let me just do x and y intercepts, and I'll show you how to do that. Well, when we're on the y-axis, x is 0. 0 plus 2y is less than or equal to 1,000. And then, so that would be 2y is less than or equal to 1,000, divide by 2, and y is less than or equal to 500. So we're at 500. Now if I do the same for my x plus 2y greater than or equal to 1,000 again, but now I make y 0, then it'd be x is less than or equal to 1,000. Because 2 times y is 0, x plus 0 is x. So now I know that x is less than or equal to 1,000. So if I come all the way out to, say, here and call that 1,000, then that's where my point is going to go. And then, so I would have a segment, let's make it red, that goes from 0, 500 to 1,000, comma, 0. Like so. It's less than, so the shading would be below. I'll do the shading after. Alright, so now I want to do the next one. So let me just erase this so I have room. And now I want to graph 2x plus 3y is less than or equal to 1,600. So 2x plus 3y less than or equal to 1,600. I'll write that twice. And I'm just going to find out when x is 0. Forgot my plus. So 2 times 0 plus 3y is less than or equal to 1,600. That's to find my x-intercept when x is 0. And then my y-intercept when x is 0. And then when y is 0, I find my x-intercept. So there's my two inequalities. So this goes away, and I get 3y is less than or equal to 1,600. Divide both sides by 3, and y is less than or equal to 1,600 divided by 3. And it's 533 1/3. Okay. When I do the same over here, I get 2x is less than or equal to 1,600, divide by 2, and x is less than or equal to 800. Okay, so now when I graph that in green, y would be 533 and 1/3. Let's just say it's about here. That is 533 and 1/3. And I'm going to go over to 800, and let's just say that's probably right about here. It doesn't have to be exact right now. Or does it? Well, let's take a look. Let's order this up. So this is 100, 200, 53, 4, 55, 100, 51, 52, 53, 54, 55, 56, 57, 58. 800 would be here. Let's keep it accurate. 59, 50, 1,000. Okay. And if we did the same on this side, if this is 100, 51, 52, 53, 54, 55 would be right here. So I need to move my dot down a little bit to 500. Might as well do this correctly. There's 500. And then a third, 533, this is 550. I exploded that by mistake. So this is 550, so it's going to be a little bit below. So it's pretty close. And then it goes to there, so now I want to draw a segment from, draw a segment from 533 and 1/3 to 800. And I might as well label that just so we know for our readers. Okay, so there we have it. So they do cross over up here, but it's really close and it's hard to see. And then, so what we know is this is our restriction. So we have to be less than this red line and less than the green. So my solution set would be, so if I zoomed in on this or made it a little more accurate, there is a space up here that we would not have. Let me see if I can make that more clear. Maybe that point should be moved down a little bit, like so. So now you can see there's a space here. They cross right here. So all this region right here should be shaded. Okay, so let me just do that with a pen. So this is my solution set. Nothing above either of the lines. So I can't go above the green, I can't go above the red over here or the green over here. So everything in this shaded region is a solution to this inequality. So what does the shaded area or shaded region represent? Okay, the various combinations of shirts and pajamas that it would be possible for the manufacturer to make. Part 6 says, suppose the manufacturer makes a profit of $10 on shirts and $18 on pajamas. How much would it decide how many of each to make? Okay, so think about that for a second. Suppose the manufacturer wants to profit $10 on a shirt and $18 on pajamas. Well, the maximum would be the most number you could make of each. Shirts is red, so if the manufacturer made 1,000 shirts at $10 a piece, that'd be $10,000. If they only made 500 shirts, they would only make $5,000. So the maximum would be at either end of these shaded region. So I can't make 1,000 shirts because that's not less than 800. I can only make 800 pajamas. So if I make 1,000 shirts, then I don't make any pajamas. Okay, so I don't want to be in the non-shaded region. My solution, so I can't go over 800. So if I make 800 shirts, then 800 shirts would be $8,000. But I can't make, let's see, then it'd be, so it'd be either end is what the answer would be. Either end of the shaded region is our maximum. Yeah. So the manufacturer, let me just shrink this down a little bit and move it over to our answer. So the answer to that is the manufacturer wants to make as many as possible, so the maximum should be at one of the endpoints of the shaded region. So it's either here where they make 800 shirts, or it's up here where they make 533, and actually it'd be this shaded region here. If they don't make any shirts, then they can make 533 pajamas. How many of each should the manufacturer make, assuming it will sell all of the shirts and pajamas made? Okay, so what they're saying here is critical points on an inequality are your intersections or endpoints. So where did these two cross? Where did 2x plus, what value is right here is what the question is. And I believe 100, 200 is, it's off a little bit, but I think it'd be 200, 400. 200 plus 800 equals 1,000. 400 plus 1,200 is 1,600. So that's the point 200, 400 where they intersect. So my critical points are 0, 500, this left end of the red. So it's the point 0, comma 500. That's 0 being X. 0 shirts, 500 pajamas. Or 200 shirts, 400 pajamas, which is right here, or down here at 800 shirts and no pajamas. So when I do this calculation, the profit, okay, the profit is $10 on shirts. 10 times 0 is 0. 18 times 500 is $9,000. So they'd make $9,000 on this one. 10 times 200 is 2,000, plus 400 times 1,800, or $18 is 18 times 400 is 7,200, which equals 9,200. Okay, so they don't want to do this because they make $200 more at this point. Now I need to just check this one. 800 times $10 is 8,000, plus $18 times 0 is 0, and that is 8,000. So the biggest profit is at this point where they intersect. $9,200 for 200 shirts and 400 pairs of pajamas. Okay, page 4 brings us to the end of lesson 24. Go to your problem set.